Hello and welcome to this video for Precalculus and Honors Precalculus about even and odd functions. So, even functions have symmetry about the y-axis, and what that means informally is that this side of the y-axis is a mirror image of this side of the y-axis. They reflect or flip over the y-axis. Odd functions have symmetry about the origin, and what that means is that they have symmetry across the x-axis and the y-axis. So basically you would take the part of the function in this quadrant, flip it up, and then over. So it's just two different kinds of symmetry. So that's how you would see it graphically for even and odd. What we're going to do today is look at how you determine whether a function is even or odd algebraically. So we'll start with even functions. So with even functions, the way you can determine if it is even is if f of negative x is equal to f of x for the entire domain. So we can't just substitute values and say and call it a day. We actually have to use algebra to sort of prove that it's even when we do this. So we have an example here, f of x is equal to x to the fourth plus 3x squared. So the way we'll test it is we'll test f of negative x. So we're going to take all of the x values and make them negative. So negative x to the fourth plus 3 times negative x squared. And if we simplify this and it results in the same as the original function, then we can say that it's in fact an even function. So let's go ahead and do that. So we have f of negative x is equal to, well, negative x to the fourth is negative x times negative x times negative x times negative x. And then plus 3 times negative x squared, that's 3 times negative x times negative x. That's really what that means, okay? So if we simplify it, negative times negative times negative times negative, that's going to be positive x to the fourth plus 3 times negative x times negative x, that'll be positive x, so 3x to the second. So when we simplify this completely, it's the same as the original function, okay? So we can say that this is an even function. Okay, so we've determined that f of negative x is equal to f of x. Okay, let's look at an odd example. So f of x is equal to 2x to the third minus 4x. Now for a function to be odd, that's what it says up here, f of negative x has to be equal to negative f of x. Do you see that difference? For even, f of negative x is equal to f of x, because they have to be symmetrical about the y-axis. So their y values when x is negative and when x is positive have to match. Whereas with an odd function, f of negative x has to equal negative f of x, because it reflects twice, once about the x-axis and once about the y-axis. So let's go ahead and test this out. F of negative x is equal to 2 times negative x cubed minus 4 times negative x. Okay, and then we're also going to look at what negative f of x is. So in an odd function, there's a little bit of an extra step because you don't start with one of your parts of your test isn't the original function, it's also this. So we're also going to say what negative f of x is, right? So negative f of x is equal to negative 2x cubed plus 4x. Okay. So what we'll do first is we'll simplify f of negative 2x. So that'll be 2 times, I'm just copying it again, 2 times negative x to the third minus 4 times negative x. All right, so let's write this out. F of negative x is equal to 2 times negative x times negative x times negative x minus 4 times negative x. Okay, so if we simplify this, f of negative x, we have 2 times negative times negative times negative. So this is going to result in being negative x cubed. So 2 times negative x cubed is going to be negative 2x cubed. And then negative 4 times negative x will be positive 4x. Okay, so because this is equal to this, and let me get a different color just to emphasize that, this was negative f of x, this is f of negative x, and they are in fact equal to one another. So this is because f of negative x is equal to negative f of x, this is an odd function. Okay. So you can pause it there if you want. We're gonna also test when a function is neither even nor odd. So if you go through an odd test and an even test and it doesn't match either way, then we're gonna say that it is neither, okay? So I'm not gonna go through that because we've demonstrated both the even test and the odd test. This function is in fact even, so, excuse me, this function is in fact neither. So if you want, you can go ahead and work out the even and odd work to see if you can determine that it is neither. I'm just kind of giving it away for you, and it's a good opportunity for you to practice the even and odd. Okay, I hope this video helped you understand how to determine if a function is odd or even or neither, and I will stop there for today. Thank you.